In this next segment, we are going to learn about graphing, specifically about work, force, and distance. So let's begin with the scenario that we've been considering throughout this lesson. A student drags a chair, and we're going to give it a constant force of 1 Newton across the floor. And what does the force distance graph look like? Well, we know it's a constant force. So as the student is dragging it across the floor, the force remains 1. So we start out at 1, and it stays 1 whether we're dragging it 1 meter, 2 meters, 3 meters, or 4 meters. So this is what a constant force over time looks like. So that's what the force distance graph looks like. Well, now let's ask ourselves, how much work was done in the first meter? Well, the first meter was over to here. We had this force and this distance. And if we wrote out a formula, work equals average force times the distance, we have 1 times 1, which gives us 1 joule. That's how much was done. Well, if you look what we're doing here, actually, we're taking this 1 and multiplying it by this 1. Well, that 1 times that 1 gives us the area, which is an area of 1 joule. Now, what about the second meter? In the second meter, the average force times the distance, well, the average force is still 1, and in the next meter, it actually went another meter, or 1. So 1 joule in the second meter. So what we did was actually measure the work from 1 to 2, and it was this force. So what we see is, what we did is there's this amount of area that we're calculating. And that is also equal to 1 joule. And then you can see that when we do the third joule, there is a certain amount of area, and that area here is also 1 joule. And lastly, if we did it for the fourth second, that would also be 1 joule. So we had 1 joule, 1 joule, 1 joule, 1 joule. Now we could have also asked a question, how much was done in 4 meters? Well, how much is done in 4 meters would be given by this, 4 meters by 1, which would be the area of the entire thing. And the area of the entire thing would be work is average force times distance. The average force is 1, but the distance is 4. So that gives us 4. As we were dragging it along, you could imagine now as we are dragging it along, we're covering greater and greater distance. 0.5 meter, 1 meter, 1.5 meters, 2 meters, 2.5 meters, 3 meters, 3.5 meters, 4 meters. As we drag it farther and farther, the area increases, and that area is the work. That is our big takeaway from looking at a force distance graph. And we would say the area between the average force and distance axis equals the work done. That's a huge conclusion. We may recall from earlier in the course, we had a graph where we had position and time, and we found out that the slope was the velocity. And you may also remember that if you have the velocity time graph, the slope was the acceleration. But it also turns out that the area equals the displacement. We have slope, which is a rate. We have slope, which is a rate. And we have area, which is an amount. And so with this graph, we have a slope of 0. So the rate of change of force is 0, but the area is an amount, the amount of work.